Okay, so welcome back everyone. Before the break, we were discussing about the 5 steps of risk assessment. Now, these 5 steps of risk assessment, these have been defined by the health and safety executive. Okay, so this approach of risk assessment which we are following is the health and safety executive approach. Now, basically, these 5 steps of risk assessment, they help us carry out a simple risk assessment. Um, First step, as we discussed, is to identify the hazard. Now, before carrying out risk assessment, we need to do a lot of study. As we discussed before the break, that there are various sources of information which we can use. So the various sources of information are looking at previous accident incident reports, inspection audit reports, looking at the health absence records, health records, and all those things. And also one more thing which is very, very helpful in carrying out risk assessment is a site visit. You must go and visit the workplace and physically see the activities which is being done actually with your own eyes. So that will give you an idea of what kind of hazards are involved in the risks, involved in the activities. So in order to carry out a risk assessment and in order to identify the hazards, you must understand the activity. So you should also look at the method statement of the activity as well. You should also read the procedure of how the activity is carried out. You should physically go on site and physically see the people doing the job. Okay. And you should also look at the previous accident and incident records in order to carry out risk assessment. So first step is to identify hazard. So after getting all this information, you will start to identify what can cause harm in this activity. So that is how you identify the hazards. Then you will identify who will be harmed and how. So you will identify what trades of people are carrying out the activity, and they will be affected from the outcomes of the activity, and who are the other people that are going to be affected by the activity. You also need to consider the people who are vulnerable, who are more prone to get harmed from this activity. So you need to identify the people who might be harmed, and you need to understand how they are going to be harmed. So you need to understand the consequences, what will happen to those workers. Then you need to evaluate the risk and decide on precautions. That is step number 3. Evaluating the risk is giving a value to the risk. This is where you are helping prioritize the risks. This will help you understand which risk is high, which risk is medium, which risk is low, and for which risk are the existing controls adequate, and for which risk the existing controls are not adequate. So this is called evaluation of the risk. And once you have evaluated the risk based on the existing control measures, now you need to propose additional precautions or further control measures. So that is step number 3. Step number 4 is to record the significant findings and implement them. So once you've carried out your risk assessment and you have identified the hazards and the required precautions that you need to take, you need to implement, you need to propose controls and then implement those controls and findings. And finally, step number 5 is to review and update when necessary. So these are the 5 steps of risk assessment. Now let's discuss these one by one. Okay, so identifying the hazards. Identifying the hazards, as I discussed, you guys, you need to look at the various sources of information, look at the sources of internal information and external information, look at the previous accident records, look at the previous risk assessments, inspection audits, read the method statement, read the procedure, and understand, do a site visit as well to understand what the hazards are of the job. So various hazards can be involved. So you need to identify what are the hazards. Usually they will include working at height, falling objects, objects falling from height, they can cause harm, moving vehicles, look at the various machinery hazards which you will be exposed to, look at the electrical hazards, look at the chemical hazards. There could be low concentration of oxygen. You could be exposed to deep water, so drowning is an issue. Fire or explosion could be there. then animals and violence. All of these are hazards which can cause physical injury. Then there are some hazards which can cause ill health. So what are the hazards which can cause ill health? They are physical hazards, as we discussed earlier, noise and vibration, chemical hazards, biological and ergonomic and psychological hazards. So these are the various hazards which can cause you harm. Okay, moving on. As we discussed, there are various sources of internal and external information. What are the internal sources of information? Accident records, ill health data or absence records, medical records, risk assessments, previous risk assessments, maintenance reports of your vehicles, safety inspections of your workplace, audits and investigation reports, and safety committee minutes. So these are the various internal sources of information, various internal records that you can examine in order to identify hazards for any activity. Then there are external sources of information. External sources of information include the legislation, the local legal requirements, the approved codes of practice, the international standards such as the British standards, and the ISO International Standard Organization. Then you can also have a look at the manufacturer's information. Whenever any equipment or machinery or any tool is manufactured, the manufacturer develops a manufacturer's information manual. So that manual, it can give a lot of information. You can look at information from trade associations and other safety publications, look at various publications from international bodies, trade unions and charities, etc. So all of these are sources of information which you can use to identify hazards related to the activity. In addition to this, you need to carry out a task analysis, analyze the job components before the job starts. So look at the various steps involved in the risk in the activity, then divide the job into small job steps. Look at the legal requirements, look at the standards and guidance documents, look at the manufacturer's information such as the operating handbooks, chemical safety data sheet, and also look at the accident, near miss, and ill health records. So these are various methods to identify the hazards. Step number 2 is to identify the people at risks. So it is very, very important that you identify everybody who is exposed to the risk. It can include maintenance staff, cleaners, it can include contractors, visitors, even members of the public and trespassers. You can consider them as well, because once that they are on your premises, they are your responsibility. Okay, so then you need to identify people at risk. When you are identifying people at risk, you need to give special consideration to vulnerable groups or individuals. What do you mean by vulnerable? Vulnerable means people who are more in risk, people who are more prone to get harm, okay? People who are more at risk from the others, such as young people. Obviously, young people, they are inexperienced, they are very, very emotional, they are very, very energetic, and they think they can do things much faster and quicker, and they don't have the adequate experience and skills. So they are exposed to danger much more than people who are of a mature age. So young people, they lack maturity and they are at a greater risk of being injured. Then there are newer expectant mothers. Newer expectant mothers have their own limitations, so we need to consider them as well. Then there are disabled workers. Disabled workers will be struggling to evacuate a premises in an emergency. They don't have the abilities as the other people around them, so they are more prone to being injured as well, and lone workers as well. So these are all various special needs people or vulnerable groups or individuals which we need to consider in our risk assessments. Okay, moving on. Step number 3 is to evaluate the risk and decide on the precautions. Now, evaluating the risk is very, very simple, and evaluating the risk is very, very important to understand as well. When you evaluate the risk, you are giving a value to the risk. You are giving a certain rating to the risk. So as we discussed earlier, that the risk is basically equal to the likelihood multiplied by the severity. Risk is a product of likelihood and severity. So in order to evaluate the risk, we need to look at both. We need to look at the likelihood and we need to look at the severity. If we look at likelihood only, then we cannot identify the risk. If we look at the severity only, then also we cannot identify the risk. We need to look at both, and the combined effect of both of these, the product of likelihood and severity, that will give us the exact value of the risk. Okay. Now, when we evaluate the risk, there are various methods. There are different ways of evaluating the risk. There are qualitative methods, and then there are quantitative methods. Quantitative methods are methods in which you give a certain quantity to the risk, when you give a certain number to the risk. Okay. So one of the quantitative methods which we are going to use is a quantitative risk matrix, which we will discuss. Is a 5x5 example. Yes, I will share an example of likelihood and severity weight. So basically, we're going to discuss about the likelihood and severity. Now, when you identify a hazard, you need to evaluate the risk. Evaluating the risk, as I told you, entails two factors, likelihood and severity. As we discussed earlier, likelihood is the chances, how many chances are there of a person being injured. Okay. This is also decided on previous history as well. It is also decided on how many people are present on the workplace as well. It is also decided on how frequently the area is visited, how frequently the task is carried out, and then severity is how serious the harm is going to be. Now, when you evaluate the risk, you need to give a certain rating to the risk. Now, as we discussed, there are two parts, likelihood and severity. We will give a certain rating to each, likelihood and a certain rating to severity. One of the most common methods used is to give a numbering, a rating from 1 to 5 to likelihood and a rating of 1 to 5 to severity. Okay, so how do we give this rating of 1 to 5? For example, if we're considering a certain hazard and it is very extremely unlikely and it has never happened in the past as well, so we will give it a risk rating of 1. Okay, so the rating will be 1, which means it is extremely unlikely. If it is likely, it is slightly more likely, and the previous incidents have not been happened in the same place, but it has happened, so we can say it is unlikely. 3 is slightly more likelihood, and we can call it possible. 4 is likely, which means there is a very high chance that the accident does happen, and 5 is very probable, which means it is certain that the accident will happen, okay, or the hazard will cause harm. So these are the various what you call it ratings we can assign to the likelihood. Similarly, we can assign a similar rating to severity. For example, if we will get a small minor injury like a small cut, we can say the severity is 1. If we might get a first aid injury in which we will need a bandage or something, then we can call it a severity of 2. Then if there is a injury which will enforce the worker to miss 1 day work, we will call it a lost time injury. So if the injury is so serious that the injured person, he might have to miss 1 day's work, it is called a lost time injury. Then if the injury is even more severe and requires hospital treatment, we'll give it a rating of 4. And a disabling injury or a fatality will have a severity rating of 5. Okay. Now, once we consider a hazard, we will look at the likelihood, we will look at the severity, and then multiply the likelihood into severity, and that will give us the risk rating. Let's go to the next slide. So this is one of the most simplest risk assessment metrics. So as we discussed, likelihood and severity, we will consider both of these when assigning a risk rating. So on one axis, we have plotted likelihood. On the other axis, we have plotted severity. On the x-axis, the likelihood increases from 1 to 5. On the y-axis, the severity increases from 1 to 5. Now, once we carry out the risk assessment, once we evaluate the risk, we assign likelihood and severity, and then we multiply to get the risk rating. So whichever category the risk rating falls in, it is called its risk rating, and it will be either red, it is high, orange is high medium, yellow is medium, green is low medium, and it is then green, dark green is acceptable. Okay, so basically what we do in risk assessment in when we evaluate the risk is we give risk rating. Let me just give you an example. Okay, now what we need to do is we will do a small exercise here. In this exercise, I'm going to give you two hazards. Okay, now do you guys understand what is likelihood and what is severity? And you also understand how we can give risk ratings to, we can give a rating to the likelihood and a rating to the severity. What I want you guys to do is I'm going to discuss two hazards with you. Okay, those two hazards will be number one, first hazard will be H2S, which is hydrogen sulfide, which is a toxic gas. If you even take one breath in high severity of, in high concentration of toxic gas, you will die. So H2S is one hazard, and the second hazard is driving. Now, what I want you guys to do is I want you guys to give a likelihood rating to H2S and to driving, and then I want you to give a severity rating to driving, to H2S, and a severity rating to driving as well. Now, once you're done, you will multiply the severity and likelihood for driving and give it a risk rating, and then you will multiply likelihood and severity of H2S and give it a risk rating. Okay, so are you guys capable of doing this? Can you guys do this small exercise? And then we will discuss how you assign this and what is the actual risk rating. So I will give you guys 5 minutes, okay, in which you will need to write down the likelihood of H2S and the severity of H2S, and then give a risk rating to H2S. Similarly, you will write down the likelihood of a driving accident and the severity of a driving accident and give a risk rating to the driving. And then you will tell me which one is a greater risk, driving or H2S. Okay, guys, so you start writing now and you have 5 minutes to do this. Yes, Suresh, you want to ask something?
Yes, STS is a high risk.
Okay, wait for the others to do, Suresh. Let's wait. So you already declared H2S is high risk, but let's wait for the others. And you need to give a rating as well. You mentioned that H2S is high risk, but what is the risk rating of H2S? What is the likelihood of H2S and what is the severity of H2S? So you need to give it a rating like 4 or in likelihood and 5 in severity. 4 into 5 will be 20. So I want 20. You to give me, yes, give me these figures. What is the severity of H2S? What is the likelihood of H2S? And what is the risk rating of H2S? Then you need to tell me what is the severity of driving, what is the likelihood of driving accident, and what is the risk rating of driving. Okay. So write this down and you guys have 5 minutes to do this. Yeah, Puneet, you want to ask something?
No, sir, it's done already.
Okay, it's done. Okay. So let's wait for the others to finish and then we'll do it. We'll discuss. Yes, Adnan, you want to say something? Adnan, you raised your hand. You want to say something? Okay, guys, is everybody done?
Yes, sir, done.
Okay, now let's have a small discussion. Now, please remember that the risk rating which we are going to be assigning here, these are not actual risk rating. I'm doing this exercise to make you guys understand how risk rating is assigned, how risk assessment is carried out. Okay, it might not be accurate. It might be different from we might have a different opinion, but this exercise will help you understand the concept of likelihood and severity and risk rating. Okay, so who is going to go first, and who is going to tell me what risk rating you have assigned for H2S and what for driving? Puneet, go ahead. You raise your hand.
Yes, sir. I'm giving this H2S the likelihood of rating 3 and
Okay.
5 for severity. So it's 15 and driving for likelihood for 4 and severity for 5. So it's a 20. So driving is high risk.
Okay, so red is high risk, so 20 falls in high risk. So you're saying
Yes.
driving is a higher risk, and H2S has a risk rating of 15, which is slightly lower, which is a medium high risk. Okay,
Yes,
anybody
sir.
else? Irshad? Okay, now we have Sufyan. Sufyan, go ahead. Sufyan, you can talk.
Sir, for H2S, it is likely, yani.
Sorry?
Sir, my voice is clear.
Yeah, it's clear. Yeah.
Sir, for H2S, likelihood is 3 points.
3, okay.
And severity, H2S is 5 points. Yani it is
Okay.
extremely damage it can cause. So it comes
Okay.
with a whole risk of 15 points.
15 risk rating
And
for
as far as
H2S.
driving, and
Okay.
as far as driving is concerned, the likelihood is up to 4 points.
4,
Yani it
okay.
could happen. And severity rate is up to 4, yani injury up to hospital level.
16,
It comes with
okay.
15, yani a
Okay.
little higher is
Okay,
risk.
slightly higher from H2S. Okay,
Yes.
Suresh, you want to say something?
Yes, sir. I'm giving for STS 4 is likelihood and 5 for severity, and
Mhm.
for driving I'm giving 3 for likelihood and 3 for severity.
3 for likelihood and 3 for severity. So risk rating for driving is 9 and H2S is high risk. Anybody
Yes.
else? Anybody else would like to say something on this? Okay, now let's discuss this. So basically, the risk rating once you give to them. So once you give the risk rating and once you give the severity, then you multiply both to get the severity, so to the risk rating for each. Now, considering both hazards, let's look at the first the severity of both hazards. Okay, when you are finding out the severity of any hazard, you need to consider the worst possible outcome. Okay, so you need to consider the worst possible outcome. Now, if you guys, I mean, if somebody is exposed to H2S in high concentration, if you even take a single breath of H2S, you can die. Okay. So what would be the severity as per the previous metrics which we have, as per the previous ratings here? The severity would be 5. It could cause you a disabling injury or a fatality. So severity for H2S is high because it can cause death. Okay, so we will give severity 5 for H2S. Now, what will happen to you if you have a driving accident? What is the worst possible outcome of a driving accident? Of course, you can die in a driving accident. Okay, so severity of driving is also 5. If you get yourself in a driving accident, you can die. This is the worst possible outcome. If you inhale H2S in high concentration, okay, the severity is 5. It is very, very severe and you can die. Okay, so in both cases, the severity is the same. The ultimate severity is death. You can die. So we will give it a high severity rating of 5 each. So severity rating for H2S is 5 and severity rating for driving is also 5. Now let's look at the likelihood. Now, because I did not give you any background information, it is difficult to determine the likelihood. However, when you don't have another information, you need to look at the previous accident records. Okay, in order to determine likelihood, you need to determine how frequently the accident is happening. Okay, how many chances are there? We need to determine how many chances are there of the accident that it will happen, how many chances are there that people will get injured from driving and H2S. Now, because I have not given you any other information, okay, the only information you can use is the previous history. Okay, now if you look at the last 10-15 years, how many people have you heard have died from H2S in your experience? Not many. In my 16 years of experience in the industry, I have only heard of 3 people dying from H2S, which was an accident here in an onshore project, in an oil and gas project. Okay, so in my experience, in the last 16 years, only 3 people have died from H2S. Okay, and now compare this with the number of people dying from road safety accidents, driving accidents. How many people die every day? There are so many deaths. Hundreds of people die in driving accidents around the world. Okay, so in this case, the likely severity of both the hazards is the same, but the likelihood of driving is much higher than the likelihood of H2S. So I will give a likelihood of 2 or 3 to H2S and a likelihood of 5 to driving. It is almost certain that you will meet an accident and get injured. Okay, so the likelihood of driving is much higher than the likelihood of H2S. So the risk rating for H2S will be 5 multiplied by 3 or 5 multiplied by 2. So you can say that the risk rating of H2S will be 10 or 15. Whereas the risk rating of driving will be 5 likelihood multiplied by 5 severity, 25. Or you can say the likelihood can be 4. 4 into 5 is again 20. So the risk rating of H2S is 10 to 15, whereas the risk rating of driving is 20 to 25. Okay, so this is how we calculate the risk rating associated with any hazard. Now, there are many other factors we consider, but because I wanted to explain you as an example, this is why I only give you H2S and driving as hazards and no other information related to that. But when you consider likelihood, you need to look at how many people are working in that workplace. Okay, then you need to look at, if you're considering the risk of likelihood of driving, how many vehicles are available in the workplace, how often you use those vehicles. Okay, how often do people go and work in H2S areas? Okay. Then you need to consider how often leakages are happening and how often H2S is being leaked into the atmosphere. So these are, when you do a risk assessment at a higher level, all this information will be considered. But at a beginner's level, this is the all the information that you need. How many accidents have been happening in the past for H2S, and how many accidents have been happening in the past for driving. So this will help you an idea of what is the likelihood of injury from H2S and what is the likelihood of injury from driving. So this is a very, very simple example which I wanted to share with you guys. If you compare various hazards, you look at the severity of each hazard, and severity you will look at with the what you call it existing controls in place, and look at the worst possible outcome. What is the worst possible outcome that you will consider in your severity, and how many chances are there of that what you call it consequence happening, or that hazard causing harm, that you will consider as likelihood. So if you multiply likelihood and severity, this is how you can get the risk rating. Is that clear, guys, to everyone, or do you guys have any questions related to this? Anyone, any questions, guys, related to this topic? Okay, so severity and likelihood and risk rating is clear, I believe. Now, once we have determined the risk rating of any hazard, then what we need to do is we need to propose control measures. We need to decide on precautions. Now, when we decide on precautions or when we decide on control measures, we need to follow a hierarchy of control measures. This is called the general hierarchy of controls. The general hierarchy of control basically helps us identify the sequence in which we need to apply control measures to reduce the risk associated with any hazard. Now, once we have evaluated the risk, now we can say that the risk is high, medium, or low. If the risk is high, it means this is unacceptable and we cannot put the workers in the way of harm. So we cannot expose our workers to high risk. What do we need to do? Now we need to propose additional controls to reduce the level of the risk to an acceptable level. So we need to bring down the risk rating to an acceptable level. How do we bring it down? By proposing control measures and by following a general hierarchy of controls. Now, when we put in control measures, those control measures will have to be put in place in a certain sequence, in a certain priority. This sequence or priority is called the hierarchy of controls. Now, the best option of getting rid of a risk is by elimination. Eliminate the hazard, there will be no risk associated with it. So the best way to reduce the risk is to eliminate the hazard. But most of the time, elimination is not possible. It is not practical, because most of the time you will have to work with the hazard. For example, can we eliminate driving from our lives? We cannot. Driving is a hazard which we have to work with. We have to get to our workplace. If we have to move from one place to another, we cannot avoid driving. We cannot eliminate driving. So elimination, although it is the best solution, however, it is not always practical. Okay, because we have to work with the hazards, because we have to use those hazards. Then substitution. Substitution is by substituting or replacing the hazardous substance with something which is less hazardous. Replacing the high hazardous substance with something which is less hazardous. For example, if you're using concentrated sulfuric acid, try to use dilute sulfuric acid. It will reduce the severity of the hazard. It will reduce the risk of the hazard. For example, if every person in your office, they are using their own individual vehicles, okay? Now, how can you do substitution in this case? You can replace all those vehicles with one bus. Put all the people in one bus. This reduces the traffic on the roads, and it reduces the likelihood of accident. So substitution, replacing the hazard with something which is less hazardous. Then is engineering controls. Engineering control basically is when you change the design of a product, change the design of the workplace, or change the design of a machinery. That is called an engineering control. Then there are administrative controls, and then there are PPE. Now, what are engineering controls? What kind of engineering controls are there? Number one, isolation. Isolation is basically when you cover that certain hazard. For example, there are moving parts of a machinery. You put a cover around it, you isolate it. Or if there is a hot part of a machinery, you put a cover around it, or a barricade around it, a solid barrier, so that you prevent access to that hazard. That is called isolation. Okay. Or total enclosure, you enclose it completely. Then there is separation and segregation. For example, in the case of pedestrians and vehicles, okay, we cannot fully enclose the vehicle route, but we can segregate the vehicle route from the pedestrian route. So we can segregate them and provide a proper hard barrier or a guardrail between the route of the pedestrians and the route of the vehicle. So that is segregation. We are segregating the pedestrians from the vehicles. We are separating the pedestrians from the vehicle, so they will not have a collision, and we can reduce the risk. Then there is partial enclosure. Partial enclosure is when you cover half of the hazard. For example, a cutting disc, okay, a disc which you use for cutting, or a bench saw. The bench saw, basically, if you cover it fully, you cannot cut anything, so you will enclose it partially. So you will give it a guard, okay, and that guard will partially enclose the blade, and it will remain only half or part of the blade unprotected, which you will use to cut the wood. Okay, so this is called partial enclosure. Then you can give safety devices, use safety devices. There are various safety devices available. For example, there are trip devices. There are other safety devices such as earth leakage circuit breakers, ELCBs, which are fitted in your homes. For example, if somebody is gets in contact with an what you call it a conductor, and the current starts to flow through his body, the ELCB will detect that earth leakage and it will trip. Okay, or there are other fuses or breakers. So these are all safety devices. Or when you are using a crane, when you're lifting, there is a specific alarm fitted in the crane. It will give you an alarm when you exceed the lifting capacity of the crane. So these are all safety devices. So all of these things are engineering controls. You are changing the design of your workplace, you're changing the design of the equipment or the tool, and these are called engineering controls. Then there are administrative controls. What are administrative controls? Administrative controls include safe system of work, having a permit to work system, having a safe system of work, having a lockout tagout system, having a safety procedure, developing a safety procedure, training the workers, reducing the exposure. For example, if your workers are exposed full time into high noise, you can reduce the exposure by giving them a break after every 1 hour. Ask them to take a break for half hour, and then, so this is reducing the exposure. Okay, reducing the time of exposure and reducing the doses as well. So reduce the concentration of the hazard that you're using. If you're using any chemical, if you are using any gas, reduce the concentration of the gas, reduce the dose of that chemical or the of that substance. Okay, so this is also an administrative control. Then you need to give information to the workers about that hazard and the controls. So that is called giving information is an administrative control. For example, toolbox talk. Toolbox talk is an administrative control. Giving instructions to the workers, giving guidance and coaching to the workers, that is an administrative control. Giving training to the workers, training the people on what are the hazards and controls of the of this activity. That is given training, and that is a administrative control. Providing supervision to the workers, okay, making sure that the workers are working under supervision. These are all administrative controls. And finally, the last line of defense is personal protective equipment, or PPE. So PPE is the last line of defense in the hierarchy of controls. Okay, then there are safety signs. There are various types of safety signs. There are prohibition signs which prohibit you from doing something. Then there are warning signs which give you a warning of danger. Then there are mandatory signs. These tell you of something that you must do. Safe condition signs and fire equipment signs as well. So these are various signs which you can use in the workplace. Personal protective equipment, as I told you, PPE, they must be a suitable supply of PPE for the workers. The PPE you use, the personal protective equipment you use, such as goggles, helmets, earplugs, earmuffs, masks, etc. All these are personal protective equipment. They must be appropriate for the risk. They must be ergonomic. They must fit properly, because if the PPE does not fit you properly, it is useless. It should not increase the overall risk. So when you are using a PPE, if that PPE is increasing the risk, then that PPE is useless to you. It should comply with the given standards, ensure compatibility of the items, the different PPE that you use, it should be compatible. If they are incompatible, they will not protect you. You need to give adequate storage as well. You need to give information, instruction, and training to the workers on how to use the PPE. You need to enforce the use of PPE. So if you give PPE to the workers, maybe they will not wear the PPE. So if the workers do not use PPE, if the use of PPE is not enforced, then obviously the PPE is useless. And then you need to replace or repair damaged or lost items as well. Okay, what are the benefits and limitations of PPE? The benefits of PPE are: number one, they can be used as an interim control while more expensive or difficult controls are being put in place. In some situations, it may be the only control available, and it may be needed as a backup for emergencies when other controls have been failed. For example, in case of H2S, usually we have so many other controls. We have what you call it, various walls in place, which can what you call it. There are alarms in place. We can make sure that the H2S is not leaked. Once it is leaked, then you need to wear personal protective equipment. Sometimes it is usually cheap as well, and it gives immediate protection as well. And sometimes it is the only control option available as well. Then there are certain limitations of PPE as well. It only protects one person. The person who is wearing the PPE, only he will be protected. So it is an individual control measure, not a collective control measure. PPE is an individual control measure, not a collective control measure. It may not protect adequately if it is not fitted correctly. So the PPE that you use, it must fit properly. If it doesn't fit properly, then it's useless. It may not be comfortable and may interfere with the job. It may increase the overall risk. It may not be compatible with other items. And sometimes people don't like wearing PPE, and it fails to warn, it fails to danger as well. Okay, so that was the 5 steps of risk assessment. Now there are certain other definitions which are important, which you need to understand. Number one is residual risk. What is residual risk? Residual risk is when you have put in the control measures. Now, after putting in the control measures, there is some level of risk which is left. That level of risk which is left after additional controls have been implemented is called residual risk. Now, as we discussed earlier, that there is only one way you can reduce the risk to zero, that is by eliminating the hazard. You can only reduce the risk to zero if you eliminate the hazard. Otherwise, you can reduce the risk to a very, very low level, to a very, very acceptable level. However, the risk will never be reduced to zero as long as the hazard is present. You can only reduce the risk to zero if you eliminate the hazard, if you get rid of the hazard. Okay, so there will always be some level of risk left after controls has been put in place, and that level of risk which is left after the controls have been implemented is called residual risk. Then there is acceptable risk, risk which has been reduced to an adequate level in which you feel comfortable to let your workers work. That is called an acceptable risk. Then there is tolerable risk. Tolerable risk is something which is not acceptable. The risk level is not acceptable, but you can live with that level of risk for a short period of time with interim or temporary control measures in place. And then unacceptable risk is risk which is too high. So that was the various definitions of residual risk and related to risk. Now, step number 4 is to record the significant findings and implement them. So usually what do you record in a risk assessment form? You record the activity or the area that you assessed. You record the groups of people who are at risk. You record the risk adequacy of existing controls. You also need to record the further precautions needed and the date and name of competent person, and you also need to give it a review date as well. Finally, last step is to review the risk assessment. So when do you review a risk assessment? You review a risk assessment whenever there is any significant change in the processes, any significant change in the workplace, any significant change in the substances that you are using. If you're using a certain chemical, but now that chemical is no longer available and you change that chemical, you need to review the risk assessment. If there is a change in any equipment, if you're using a certain equipment, but that is no longer available, you add a new equipment, you need to review risk assessment. If there's a change in the workplace environment, you need to review the risk assessment. If there is a change in the personnel, also you need to review the risk assessment. Or if the risk assessment is no longer valid, so you need to risk assessment if it is no longer valid in case of an accident, in case there is a near miss, in case of ill health, or if there is a change to the legal standard. So if the risk assessment is no longer valid, you need to review the risk assessment as well. Now, if there is no change at all, and there is no accident, there is no changes at all, you still need to review the risk assessment at a regular period. So periodically, you need to review the risk assessment. Usually companies set a periodic review every 1 year or every 6 months, depending on the nature of their activity. So this is very, very important. You need to understand when to review a risk assessment. Okay, guys, let's take a small break before we continue. We will be back. It is 4:42 now. Let's take a break till 4:55, and then we'll be back and we'll cover the remaining parts of this element. Okay. So let's break for 10 minutes and we'll be back at 4:50. Let's make it 4:55. 4:55.